Good morning. Welcome back to Vulkanised for day 2. Nice to see you all again. I actually want to start by saying how thrilled I am to see such a large number of people come to this. When we first were talking about putting this together, I didn't know if we would get 30 people or 130 people, and I'm really pleased to see more than 130 people. And it's just absolutely wonderful, and it aligns a lot with about what I'm about to talk about with getting Vulkan out there to everyone. So a little about me. I'm a staff software engineer at Google. I spent 15 years in game studios, largely as a rendering programmer before joining Google. Since then, I spent 5 years working in the graphics space on Stadia. That role brought me to the Vulkan working group, which I've, since Stadia ended, I ended up pivoting that into a role in Android to continue my work with Vulkan. So I want to go through a few things. I want to define Vulkan for all. I admit the title is a bit provocative, so we'll get to that. Offer a bit of criticism, discuss some of the current solutions to that said criticism. And then I want to talk about the ecosystem a bunch. And then hopefully we'll have time for questions. This is supposed to be 30 minutes, and I think I have 50 slides. So I'm going to try and plow through them rather quickly. I do have a goal for this, which is to align us on the future of Vulkan. I think I'm not actually going to say too much that a lot of people don't already know, but I think there's some value in it coming from one voice, and to try and spark some of the conversation on what we can do to improve as an ecosystem. So first, let's define Vulkan for all and what I mean by this. It could be all platforms, all developers, all accelerators, or all applications. And it's really this that I mean, all applications. In the sense that all applications can use Vulkan to access the accelerators that they need, which implies that developers are enabled to use Vulkan where they need to use it. And that implies that Vulkan is widely available and in a good state where it's available. And we're not there yet. We could broadly describe the problems as fragmentation. But there's API complexity that's a bit of a barrier, and there's a lack of education material, and there's reasons for that, and I'm going to get into that. But denying that that's the state is part of continuing it. So I think calling it out and identifying that these are problems that need to be solved will help us take steps to solve them. So even a bit more meta, what is Vulkan? When we talk about Vulkan, what do we even mean? And to some, the first answer will be, it's a graphics API. Well, of course it's a graphics API, but it can also do compute. And some people use it just for compute. And it was even designed with this in mind, which is why the WSI stuff is separate, and is even implemented separately depending on the platform that you're on. We've got video now, so you can even just use it for video to encode, use the video encoding block on most GPUs. And ML is on the table. Some of these things are controversial because people really anchor on it's a graphics API, but it's like closer to a high level how that can be used to program accelerator devices in a consistent way. So I would define Vulkan today, or this is how most people think of it anyway, is a broadly implemented specification that provides APIs to program accelerator devices. That includes graphics devices and all the other things that we've talked about. The other barrier is Vulkan is hard. It contains complicated concepts that other APIs don't, like the per stage pipeline synchronization. It catches people out sometimes. Transient attachments, Hilariously, I have a note here, something about image layouts. And I don't remember what my point was. There's something about image layouts that's different than other APIs. There's a large set of hardware. We're trying to cover everything from 5 watts to 500 watts. And this was brought up in some of the discussions yesterday. And that leads to some things in the API, like render passes. The way the queue families work when you're first trying to wrap your head around it is confusing. And all of this is about trying to support this large set of hardware. Extension proliferation, many extensions, probing the feature bits, all the device cap handling that you need to do. All of this stuff is weight that makes consuming the API directly very difficult. It's not, once you get it, it's not too bad, but it's still a large volume of code and it's error prone. And then on top of that, there's also like some vendor extensions and stuff like that. Vulkan is also enormous. And I have some stats on this because it's enormous and growing. So in 5 years from 1.0 to 1.3, it's roughly doubled in terms of commands and extensions. And I don't have, the last 2 years, I don't have stats on what a future 1.4 will look like, but I think it's something like another 40 extensions or something. And a lot of you probably don't care about a large number of this to solve your particular problem. So it makes consuming the API, again, very difficult. If you've ever tried to, here's a tip, actually. Keep the spec in PDF form on your local machine. If you go to the website and you have to wait 10, 15 seconds for it to load, there's the chunked HTML, which helps, but I keep a local PDF. And it's because it's so huge, it's enormous. So I'll offer some of my opinion here. And a large part of this, actually, I should have led off with. The large of this is my opinion. I really like Vulkan despite all of this. I strongly prefer a standard API over proprietary API. And like I've alluded to, that's not to say there's some things I don't find annoying. One of the things that always caught me out was the frame buffers. Frame buffers had this really surprisingly invasive way of getting in the way of trashing my abstractions. I always could never figure out, like, I need the frame buffer here, but it's over there, but I don't have it yet, and it was really annoying. Dynamic rendering probably solves that, but there are things like that creep up. And as noted, probing all the extensions and feature bits. But Vulkan is really important to Google. We believe in it. We believe in the way it's developed. And it's the preferred graphics API on most of our hardware. I'd really like Vulkan to be the graphics API. So kind of another anecdote. Recently, I was writing a fresh toy Vulkan renderer from scratch to exercise some of the new extensions that have come out, like dynamic rendering and graphics pipeline libraries and stuff like that. And I wanted to write it the way a game developer would write their renderer, because I haven't been working in a game studio for 5 years. I've been working on the spec and stuff, but not exercising the API directly myself in terms of working on a game engine. So I wanted to go through that exercise. So I thought, okay, I'm going to write it, abstracting away the back end. So I could maybe support DX12 and some other stuff. And I thought, why am I doing this? Like, Vulkan should be the abstraction. And why am I having to abstract away the API? Vulkan should be the platform abstraction for graphics. But it's not. Like, the reality is there are places where it's not available, so that is how they'll have to write, how game developers will have to write their stuff. But overall, fragmentation, like this type of thing, is a huge problem in the ecosystem. There are some tools that can help. I'm going to go through this pretty quickly because I'm sure most of you know this. And this is the solution that we've taken till now in the ecosystem. So validation layers, right? You should be using the validation layers 100% of the time when you're modifying your rendering code. Some people will say, I can't, it's too slow. Well, you should have a render test level. I know that, like, I'm just saying, yes, you could do that, but then you need like some artists to build it, and you have to figure out how you're going to exercise all your materials and all your render passes. But that's what you should do. That's honestly what you should do. And you should always have the validation layers running. you should be using VMA. And I'm going to talk more. This leads into something I'm going to talk about later. But in my opinion, if you're not using VMA, you're not actually doing Vulkan correctly. You should be doing this. This should be de facto standard way of managing memory and buffers in Vulkan. But the samples don't use it because they're demonstrating raw Vulkan. I'm going to come back to that. This is probably the only code you're going to see in this. This is a really philosophical talk. It's not going to be much technical. But here's like an example of how you can use VMA to create an image, and then you can create it like this. And it's much less code than trying to do it raw. And this is not anything that I've written aside from wrapping it in some objects. This is all the open source stuff that's available now. And it massively reduces the amount of code that you need to write. You'll notice I'm using the Vulkan HPP. I'm going to get to that in a second too. But all of this is like available now. It's part of the ecosystem. And on that, like the Vulkan HPP, you should probably be using this as well. This took me a while to come around to. I didn't like it at first, but it was the RAI objects that were recently added that hugely simplified my life. And you'll see that in this slide here. I've got it in there where I'm stuffing the image in an RAI image. And it acts similar to the COM pointers in DX, except the object exposes all the functions. So you can actually just go find the object in the header, and it lists all the functions. You can see what parameters they take and all of that, which makes navigating this stuff a bit easier. So I've come around to this, and I think if you're doing Vulkan and C++, you should be using this. It has some other nice things too, like the syntax integrating with the IDE autocomplete. And one of the cool features is type checking the pnext chaining. So you can, it uses the spec to know whether you're allowed to pass a substructure and a pnext of another type, which helps reduce mistakes. There's similar bindings in other languages. The Rust bindings look similar to this. You should probably be using Voc. If you're using the Vulkan HPP, like I just said, you don't need to use Voc. It's got its own dispatcher in it. SpearV reflect. You should probably be generating your descriptors from SpearV reflect. Some of the bindless stuff that we were talking about yesterday maybe makes this a bit obsolete now. I need to go through that exercise and see how that would work. Some other ideas. Pipeline management. We could probably have a library similar to VMA that does pipeline management, sniffs all the extensions, determines if graphics pipeline libraries is there, works out how to most optimally create these things. Maybe it can figure out how to reuse pipelines. I've got this one that's close enough. We'll use that, and then we'll swap it in the background later, something like that. People are writing this stuff in their engines, and we could have de facto standard ways of doing it. Maybe queue abstraction. I was back to my toy renderer. I had written something, and then I was running it on my laptop, and the laptop only had one queue, like literally only one queue. So I couldn't. There was no way for me to do any async loading. So why do we need these things, other than just because the API is complex? Partly it's because of how the spec is developed. So like GL style APIs can hide complexity and hardware differences in the level of abstraction that they have. It's very difficult in an explicit API such as Vulkan without pessimizing something, somebody's hardware or the API or something. And we can't do that as a group. We have a set of inputs and a set of needs that need to be met. So to solve it, generally what we do is we hoist complexity out of the driver, out of this API, and into the application space. So that's all the sniffing of the extensions, sniffing of feature bits, device caps, all of that stuff ends up getting exposed. It's kind of a leaky abstraction. And then the application is forced to handle all of those cases. Some people call this design by committee, but I think that's actually deeply unfair. Design by compromise might be more fair, but that still doesn't respect the complexity of the problem that we're trying to solve. And it's just the reality of how we have to develop this API. But this has had a kind of an interesting result, and some of this was talked about yesterday. The surprising result of bubbling all of this stuff up has been the success of some of these layering technologies. Angle, DXVK, Zinc, VKD3D. They all have performance on par with the native implementations. Not 100%, but on par. And that's pretty surprising, actually. And when you start thinking about it, it's not that surprising. A graphics driver is huge. There's some people in the room that have worked on graphics driver. They're enormous. They're like little operating systems. So like one extra little layer isn't killing you. There's some API friction, and some of these have been enabled with special extensions in order to make this possible. Like we'll leak a little bit more out in order to enable building this layer, and it just doesn't add that much. And I think that that's really great, and there's really strong evidence that Vulkan actually makes a really great HAL. Another red slide, so more of my opinion. I think we need to embrace this and expose more low-level stuff. And that really mean options and flexibility. So low-level is not an accurate term, but things like virtual memory, maybe directly exposing tiling hardware instead of wrapping it in the render pass thing. We need to think about these things, but I think if we do it right and expose this stuff at the leaves of your renderer, so it's kind of more of a last-minute decision instead of at the root, like render passes are the root. You need to know ahead of time what your render passes are in order to exercise that API correctly. But if you do it more at the leaves, it's not as much of a problem. And then we endorse this gap with application space libraries like VMA, maybe like the pipeline library that has been suggested, to reduce that complexity. So you might say, well, okay, well, why don't you just put that in the spec and have all the drivers implement it? Well, it's largely because then all the drivers have to implement it, and they're all going to be doing largely the same thing. So why are we making everybody implement this same thing in roughly the same way? Let's just lift it out and have an open source solution to that. The challenge is how to develop this and how to fund it. And one of the problems we have is there's no one in control of what we're doing, really. And I'll come to that in a bit. There are some pros to this, right? Like I mentioned, hoist complexity out of the driver. It could reduce special extensions. That should be could, not should. It could reduce the need for, there was, as an example, there was an extension proposed to do mipmap generation. But maybe we shouldn't do that. Maybe it should be, that sounds like an application space library that should be doing that. And then maybe if somebody has some special hardware that makes that easier, the application space library should just utilize that hardware when it can. So I would say anything that can be implemented in app space should be. But then this counts on users to use the libraries. And if there's a tendency for developers, especially game developers, to want to directly consume what they think of as the API that they're consuming and write all of their own abstractions. And going back to I wish I had a diagram for this, going back to the volume of code that is in a graphics driver, like you're sort of fooling yourself if you think, well, I'm going to be as close to the API as possible for whatever my reasons are, whether it's performance or I want to be in control. Like there's a mountain of stuff under that already. So like one more layer is not going to kill you. It's because you can see it. There's a bit of a psychological thing here. It's like, I can see this code, this open source code, and therefore it's in my way or something like that. But as soon as it goes black box, people tend not to think about it. Vulkan is different than other APIs. So I alluded this a couple of slides ago, that like there's no one in control. We have similar goals to other APIs, but different constraints and resources. This ecosystem is a community, and we need to accept that and work within those limits and constraints, right? We can leverage the strengths, so we can create an even lower level API possibly, move functionality to application-based libraries. But then we need to make those libraries standard or de facto standard. And so that's going back to my thing. If you're not using VMA, you're not using Vulkan correctly, in my view. And I think there's space to grow that even further. I've lost my flow. So yeah, so Vulkan is an ecosystem containing the spec, implementations, drivers, all the libraries, all the tools, and the community and of companies and developers. So the challenge is Vulkan is not driven by one agenda or company. So other APIs have this vertically integrated API, sometimes even including the hardware, the tools, and all of that's built as one thing. So at the top of the talk, I said I prefer this model. I prefer the more sort of open, not sort of open, actually open model of developing and working on the spec and all the tools and libraries around it. But the challenge is then, like, really, we don't have much direction. It's low direction. It's a bit chaotic and messy, and it leads to that compromise of what ends up in the API. And the word compromise even, it's not meant to be negative. It can be positive as well. We've collectively decided to do this in a certain way for the benefit of everyone. So it's not negative, not compromise in a oh, that's a compromise, but the enabling everyone to be part of the ecosystem. So with that, I want to redefine Vulkan. At the top, it was something about being able to program accelerator devices. So now I want to say Vulkan is an open ecosystem containing a broadly implemented specification, plus the collection of tools and libraries that enable one to program accelerator devices. So then the path to Vulkan for all is the spec should be designed with layering and application-based libraries in mind. We do that a bit already, but I think we should ingrain that. The application-based libraries need to serve a need, be high quality and funded somehow, either through the goodwill of the community or directly from companies or something in between, developers working at companies. Like VMA was donated by one of the member companies. Some of the other bits, SpearV Reflect, I think, came from Stadia and is now part of the Khronos repositories. Things of this nature. The samples and other education material also need to be using those libraries. And the community then needs to consider the ecosystem overall as Vulkan. So instead of just looking at the spec in the API and saying that's Vulkan, we need to say Vulkan is the spec, it's VMA, it's SpearV Reflect, it's all of the stuff that we decide is the de facto way of doing it. And that's it. That's my opinion. Wow, that came in almost perfectly on time. I'm really happy with that. So we got about 5 minutes for questions if anybody has questions. Yes.
React to the comment on Vulkan campus. Is that really true for the whole Vulkan or just graphics? But from my perspective, Vulkan compute is not particularly harder than anything else. So it's really just graphics. That's kind of considered difficult.
The Vulkan compute being difficult?
No. I mean, it's among the different things Vulkan can do. I think it's really graphics that's most difficult. Not, like, I don't know about videos as well.
Yeah, no, that's true. That slide, yeah. So the question is it's really just graphics that's difficult, not the compute bits, and not sure about video, but I'll come to video in a second, actually. that slide was not meant to be like, these things are adding complexity. And I agree actually with your assessment. It's really graphics that is the complex bit. And those things don't add significant complexity. The only complexity is when you're trying to figure out what you want to do to solve your problem, is the spec is enormous because it's got all of these things in it. But yes, I agree. That doesn't add inherent complexity itself. Whether video or not is complex. There was a blog post that came out that more or less asserts that it is really complex, but that actually aligns with what I'm talking about. Like, it's exposed very low-level set of stuff that's not meant for you as the developer to consume directly in your app. It's meant to be used through something like FFmpeg or some other library that somebody's written, maybe us as the community, and endorse that as that's the way that you will integrate that with your application. Another one? Oh, yes.
What's the process to define what is the standard or what's not? Examples of tutorials which mean that Vulkan can promote in on every application. But what's the process?
Yeah. I think on one hand, market principles apply. So we need to talk about it, and then a critical mass, if a critical mass are doing it that way, then it is the de facto standard way of doing it. There are people in the Vulkan working group who are also working on some of this stuff. And if we're able to develop the spec and a companion library alongside of it, then it has more chance of this becoming successful. There has been discussion on whether we should spec the libraries, but this is, the interesting challenge about this is Khronos really isn't set up to work that way. Khronos is set up to do spec, and we do a pretty good job of that. Look at how fast Vulkan has doubled in size and how many more extensions are coming, have been come since 1.3. I think I said it was about 40. We're really good at generating spec. Like we can churn out spec all day long, but then there's no support for it. And so we've created this API, and it's like, go forth and create graphics. And I think we need to, as a group, figure out how we're going to do that. So it's a very good question. So I'm saying we should, and I'm not saying how. Very fair. Yes.
Right? We need to have spec.
Yes. Yeah.
So last quick one. One of the problems we have with developing Nabla, for example, is that we are trying to obviously represent like another wrapper on top of it. And one of the things that we do is we have to decide which extension we're going to expose and what, and how to query stuff. And if there's two ways of doing things, then only present the most recent one. And the problem that we have is that the spec grows faster than we can read it.
Mm-hmm.
And actually think about it. So what do you think about like some kind of a mechanism of deprecation, or just publishing like a version of the spec that only contains like, for example, timeline semaphores and all fences and so on?
Yeah, this is really tough. So the issue is that once an extension is out there. Oh, sorry. Yeah, sorry. Thank you, Karen. So the question is, what do I think about deprecating parts of the spec and making them unavailable so that there's one way of doing it? I think that paraphrases what you were saying. Yeah. The problem is there's an actual. The real issue is you have a graphics driver that exists on the device. If at any time there's an extension available and somebody picks it up and starts using it, it must be available forever. And because so the implementation, the graphics driver implementation, needs to continually contain all of that old spec. Maybe there's a way that we can present this is the new way of doing it. Ignore the old one. and on some level, we try to do that in the way the spec is presented, like synchronization 2, for example, is like you're supposed to do it that way, ignore the old APIs, but all the samples still do it the old way. And so this is part of the problem that I was talking to with how we present documentation and samples and stuff. I'm gonna have to think about if there's an actual way to do that. I don't think there's an easy way to do it. There might be something we could do. Yes.
I was just going to say on that, one of the problems.
Yeah. So the comment was that the games have a long tail. They're out there for years, and they need to keep working. So those graphics drivers need to keep that functionality present. So if they're implementing the spec as it currently is, then all those extensions need to remain in the spec. And this actually, that kind of, I think the answer to your question is like, is the spec documentation or is the spec for graphics driver implementations? And that is a challenge that we have. So you all reach out to the spec to figure out how to consume the API, whereas other APIs don't do that. They don't even have a spec. They have like a reference implementation and some documentation. So yeah. Yeah, because we're bleeding into the next person. I think we'll do one more because we've got the hand has been up for a while. Yes.
I see that there's a lot of work going into how we from the CPU side. Maybe that's a bit of a personal opinion, but I think that the bottleneck of Vulkan right now is how we develop shaders. So having the shader code in source, do you see any future possibility for this, or is something?
I'm not sure what you mean. Can you rephrase that? And then I'll repeat it once I get it.
Like right now we can write shaders in GLSL or HLSL. These languages as they are right now are pretty limited. So especially for people that come from CUDA, for instance, that are used to using C++ and pointers and all the and lambda functions and operator overloading and all that kind of stuff. Do you see any future in that regard for Vulkan?
I don't know for sure. So the question is, do I see a future for language improvements in shaders? Like the current shading languages are a bit limited. This has been discussed quite a bit, especially the GLSL, HLSL thing, and especially with DXC coming out and having support for a SPIR-V backend. This is actually, you've touched on something that's actually a challenge in the ecosystem right now on how we're going to do this. Nobody's, I wouldn't say nobody's thinking about it, but somebody should be probably thinking about it. There are people that are thinking about it, but it's not being actively pursued right now, I would say. But there's room for improvement here for sure.
Okay, for instance, like merging OpenCL kind of shader development.
Yep. Okay. I think I'm eating into someone else's time. So my email address is up there. Feel free to shoot me an email.